Hey guys, in today's video I want to talk about upgrading the fan assembly on the Ender 3 V2. I've been curious about a lot of these fan shrouds and stuff that you find online. This one was particularly interesting to me when I saw it. What I didn't like about it is how bulky it was. So this is a very bulky thing, even though compared to some of the other ones, it is much smaller. And there was another one that was reviewed by another guy. I'll put a link to his YouTube channel. He did a good job comparing these different fan shrouds and how they flow. But this one was also very interesting to me. I thought it was a cool looking design. And anyway, I started printing it. But what I don't like about any of these is that they're extremely bulky. I mean, if you gotta add this much size and length to these ducts, it makes them less effective, especially when you're dealing with these the stock parts cooler that comes with the Ender 3 V2. It uses these small 40-10 fans, and you can't have very long ducts on this because it's just not going to flow right. What does work extremely well is the stock setup. The stock setup is just awesome. I mean, really, it's very compact. It looks great. The flow characteristics are really good. But what I wanted to do is I wanted to add a second parts fan. I don't like just having cooling from one side. When you look at some of the prints that are just cooled from one side, they tend to look good on that side, but then the other side does not look as good. So this is a good example here. So I printed this one up, and it was printed. I believe it was facing this way. It was facing this way. So it printed facing this way. This side came out looking really good, but then this other side, not so great because it wasn't getting parts cooling from this side. So unfortunately, when that happens, the whole part doesn't look really good. So here's another issue with printing these small parts, and that's why you really need the extra cooling on the other side. You don't want to have crazy cooling, because if you have too much airflow, then you get a lot of stringing. That's at least what my experience has been. So here was another stock fan or duct for the Ender 3 V2, but this one compared to the stock one is very bulky. So if you look at the original one, so here's the original one here, and you can see the original one is much smaller than this one I found on Thingiverse. So they're not even remotely close, and then trying to get these little fasteners to print is a big time problem. What I wound up doing is I took the stock fan out of here and then really examined this duct. And what I wound up doing is I designed my own version of it. And here it is right here. So this is my version of this duct. You can see it's pretty close. Pretty close. May not be 100%, but it's very close. The way it fastens is the same. The only thing I left out was the little arms to hold it to the fan assembly. I lengthened this on the current version of this that I made so that it just slips in and just holds in there by friction. So it's a friction fit fan duct, and it works really well. Another thing too that I found that was really cool about this is the compact design. So they packed a lot of stuff in a very small space here with this setup. You can see they got the parts cooling fan butted right up against the heat sink fan for the extruder. And anyway, this is a very, very efficient design. Now, one thing that I did notice on this is that the fan is offset to one side. And the reason they did that is because it would have interfered with the gantry. So when the head moves over to the right, the far right side, it would have hit, which is something that I learned when I was starting to play around with a redesign of this. So anyway, what I decided to do is build my own, and I went through different versions of it. So this is the first version to get kind of a rough idea of how this thing was going to fit. And I have a video on how I got up to this point using a picture that I took of the hot end and then building the part around that picture. It's pretty cool that you can do that with Onshape, and I'm sure that other CAD programs have a similar feature. But anyway, this was pretty cool to me, guys. So I'm gonna move through this portion of the video pretty quick. I don't want to bore you guys to death. I fumble around pretty good with this Onshape, but first thing you want to do is start by creating a document. Just give it a name. And then once it loads up, next thing is going to be to change the workspace units. It defaults to inches, but I like using millimeters. And now what I did is I took a picture of the hot end with my cell phone. I just emailed it to myself. And what you want to do is you want to put it someplace where you know where it is. So I think I'm just going to drop it on the desktop. And then you want to insert this picture. So we're going to click on this little plus, and we're going to add the image to our document. Once it's in the document, you're going to create a sketch, select the plane, and then we're going to insert the picture using this little insert tool here. And what you got to do after you select the picture, you got to kind of draw a square on the plane where you're going to put the picture, and then just let it go. And then what we'll do next is we're going to size it properly. And how you do that is you take a measurement, a physical measurement of 2 points on the original part that you took the picture of. So in my case, I took a measurement between the two bolts that hold the hot end onto the gantry plate. So all we're going to do is just draw a line between those 2 points. And once the line is drawn, then you're going to give that line a dimension, and then that's going to properly scale the image. So now anything that you build around this image will be accurate. All right, guys, so at this point I'm going to put this thing on fast forward, and I'll just briefly talk about what I'm doing during these next processes. So first thing I'm going to do is I'm going to center the picture into the work plane, and then I'm going to draw the box that's going to hold the heat sink fan. So all I'm doing here is I'm going to define the 4 edges where the bolt holes go. So that's why I'm drawing this X here. I'm going to put a point, another point, another point, another point. And then now I got my spacing for the bolt holes. Now I'm just going to give those bolt holes a size. And then that's pretty much it. Now what I'm doing next is I'm creating a secondary plane This is to give my object the depth that it needs to have. So I'm just doing a quick little calculation here to find what the difference needs to be. And so now I'm going to create another drawing on this next plane. And this is going to be the part that's going to hug the heatsink. I'm going to give this thing the sizes that it needs to be. Right, now the next thing that I'm going to do is I'm going to create a connection between these 2 points. And Onshape has a feature called Loft that you can use. And that will allow you to create, mate 2 different shapes together. So for some reason my loft wasn't working, so I had to redraw the lines. So what I'm guessing is you need to create the loft before you do anything else to the picture. But no big deal, just redo it real quick. The next thing I'm going to need is the measurement of the fan diameter. So I just grab that real quick. And then to cut out this, the center bits of this shape, I just use the shell command. So the shell tool will allow you to hollow out a shape, and you can just pick whatever wall thickness you need to have. What I'm doing here is I'm adding the places where the screws are going to go into. Since I hollowed out the rest of it, the screws are going to need to hold on to something. Now what I'm doing next is I'm going to create the face for the fan. Give that thing a size, and then I got to create an outside shape that I'm going to extrude out. So this gives me my place for the fans. Now I just need to make sure that I pass these holes for the screws all the way through the front face. So I'm going to try to see if I can make some holes here. And I fumble around still with this program. I'm not an expert by any means, but I learn as I go. And if one way doesn't work, I just try a different method for achieving the same result. So I tried using the hole command here, but the hole command wasn't working. So what I wound up doing was just creating another sketch on this new surface. And now I'm extruding and removing material down into the box that had those little cylinders for the screws to fit into. Alright, so now I'm going to create another plane because I need to make an opening on the top for the Bowden tube to fit through. And I also want to make some openings on the side for air to escape from the heatsink. And this is just more of a first run prototype. So it doesn't need to be perfect by any means. I just want to get a rough idea of how this thing is going to fit. And then as I look at it, I'll make adjustments to it. So this process took me a few hours to get the whole thing done. This particular shape didn't take that long, maybe 30 minutes. So what I did here is I created a secondary shape, which is the size of the heatsink, and then I just used the boolean tool to cut away at the shape of the fan shroud. Okay, so now I got my boolean the way I want it. Now what I'm doing next is cutting out the top part where the heatsink is going to be. So the bottom was for the heat block, and then the top is for the heat sink. So that's why I got a wider opening on the bottom than the top, is because that heater block sticks forward from the hot end. So now I'm just drawing some shapes on the side here just to make some openings. And how you can get this view is there's a little box on the right corner there, on the right side, that has a drop down. You can click on that box and use that box to give you a translucent view of the object. So in case you got to look through it to see where reinforcements are, that way you can be accurate with your drawings. So I'm just going to hollow out this shape here all the way through. And this was that first piece that I showed you prior to showing you this construction video. And each process, each stage was something similar. It was just me going back and further modifying this file until you get the shape just right. So now I'm just going to export this to an STL file. Open up Cura and print it off. And so I decided to add a radius to all this, make it look a little bit cleaner. So I'm going to re-export this again. All right, there it is in Cura. And I'm going to put it face down. I like to try to design my parts to where they're printable. If you get all artistic and fancy, then you got to start adding a bunch of supports. But I know pretty much what the limits are of the printer, so I try to do my best to design the parts in such a way that they can be printed. So this was the first version, and then I attached it to the hot end, put the fan on it, and then checked it. And then I came up with a different version, which is, let's see, where is it? This one. So this is the second version of this. And what I decided to do is conform it around the hot end. And then the one after this, I added a little tab here on the inside to grab the back of the hot end. You can see that's this version right here. So I added this little tab. But I was having problems with these little circles and it not cooling the filament. When you're dealing with printing small parts, what happens is as the hot end is moving around, since the part is really small, as it comes back to put another layer down, the previous layer hasn't totally cooled. And that's why you get a lot of distortion and issues with these smaller parts when you try to print them. So anyway, from this stage, I went over to this version, and this version was much better. And then what I did here, from this one to this one, what I did is I hot glued the parts cooling fan on one side to allow me to cool as I printed this piece. And you could see the quality improved quite a bit as opposed to this one that didn't have hardly any parts cooling. So you see a lot of the distortion on the plastic. But this one started to come out much cleaner. From this point, I decided to add the side support for the fan. And let's see what the next one is. And then we came up with something like this. So this slowly been evolving from one to the other. And then what I noticed from this one to this one is the position of this fan. So when I hot glued the fan to the side of the previous one, it was hitting the side of the gantry. So then that's when I realized that the reason that Creality moved the fan over to the side and it was offset was to give extra clearance so this part would not hit the end stop. So anyway, we went to this version. From here, I noticed that the fans were placed, they were sitting up too high. So from this, we came over to this part here. So now on this part, if you can see, this one has this top edge even with the top of the fan. This one just got slightly moved down. So you can see that it got moved down a bit. And anyway, I was getting closer and closer with the final design of this. The next to latest one is this one. And so what I added here is a point that we can run the wires on this side fan to hide them so that they're not hanging all over the top and looking all messy. I also had to notch out, get these out of the way so you can see. I had to notch out this part over here because there's a bolt that sticks out, a head of a bolt that sticks out here, and I needed to provide extra clearance. One thing that you're also going to have to do is modify one of these parts cooling fans. So this is the fan that goes on the left side. I had to take this to a grinder and grind it down a little to make that clearance for that bolt. But once that was done, then it fits really well. And you can see that the little slot makes a difference. And on the latest version, I've increased the diameter of that slot some, so it fits even better than this one. Anyway, so it goes together like this. And yeah, that's what I was after. I was after a really compact design with a friction fit duct that I could use. So here, let me show you how the duct fits. Let's see if I got one around here somewhere. Here's one. Okay, so this is one of the ugly ducts, but let me show you how the duct goes in. See, just friction fits in there. And this was one of the prototypes, so it's not 100%. But let me show you where we're at now, currently. Guys, over this side so you can see. So right now, this is the most recent version. And what I did on this one is I also included a groove behind the fan. It's just an opening so that the wire can go through. And I'll go ahead and hook all this up and show you guys what it looks like. But yeah, the fit is really good. I'm going to be really pumped up to get cooling from both sides. So let me go ahead and start putting this thing together and then show you guys what it looks like. Here it is all assembled. I got the wires all organized, the fans installed, the ducts are in. I even found a way to route the BL, or actually the CR Touch cable around the back, make it look a little neater. I didn't like it hanging out at the top. It was looking pretty ugly. Anyway, so this is what it looks like from the front. So you can see you got the dual ducts are there. And the nice thing about having these fans pressure fit is that you can move them slightly. So you can tilt them a little bit back or side to side a little bit. It's kind of cool to be able to have that a little bit of adjustment. But the true test is airflow. And right now I have the printers on, and you don't hear this this fan at all. The fan noise you're hearing in the background is the CR10S Pro that's currently printing. But I'm gonna run a quick test here. So I got a little bit of water in a lid, plastic lid. So what I'm gonna do now is I'm gonna turn the fans on. And right now I got the gantry. Let me check the position of the gantry. Anyway, I'll turn this on. Let me check the gantry position. And I got a noisy fan. It'll get quiet here in a minute. There it goes. Wow, crazy loud. Anyway, right now I have the Z set at 60, so it's 60 millimeters off the bed. Fans are full blast, and so here's our water movement at the current level. So now what I'm going to do is I'm going to bring it down to 40 millimeters. All right, so I'm going to move it down to 40 millimeters. So at 40 millimeters, you can see that you're already starting to see a point in the water. Let me drop it down to 30 millimeters. Now at 30 millimeters, there's a significant point. Let me move the camera so I can show you. So that's at 30 millimeters. So I'm going to drop it down now to 15 millimeters. That'll put it right over the water. You can see I have a good amount of airflow right there below that nozzle. I mean, it's really flowing good. So if that was a part that you were 3D printing, getting that kind of airflow right above the that far below the nozzle, that's good airflow. So I'm going to turn the fans down because I don't like the fans being this noisy. I mean, there's two of them, so they're making a little bit more noise than regular. But I'm going to turn the fans down to, let's see, turn the fans down to 50%, and we'll check our airflow and see if it's impacted by reducing this to 50%. So there it is at 50%. significant drop in noise, and yet we still got awesome airflow. So I'm going to try to turn it down some more. We'll test and see how far we can go before it doesn't move any air below the nozzle. So we're currently at 50%. So I'm going to half this number. So that would make it 62. Let's make it 62. So right now we're running at 25%. And you can see that we still got air movement right below the nozzle. So if you were working on a small part and you don't want to have a bunch of stringing, you can turn this thing way down. I mean, at a quarter of the speed, and still you got that kind of movement. I think at 50%, this thing works really well. So you got not nearly as much of the noise, but very good airflow. So guys, that's 50% on the fan speed, and that's really good air movement, and it's directed in just the right place. It's not off to one side or anything like that. It's directly below that tip. Anyway, I like it. I think it looks really clean. It's not going to win a beauty contest. It is a ugly spud, but it's clean. It works. For me, the performance is more important than the look of it. But I think 95% of the people out there that aren't going to print very small things, and you're just printing larger items, the stock hot end assembly, fan assembly I meant, is sufficient. I mean, it did a great job. I just wanted that extra airflow. And I think getting air from both sides will actually reduce stringing. Because if you were going to run it up at a high speed, you're getting air from both sides. So you're not going to have strings on swinging over to opposite the air movement. So anyway, guys, if you like the video, consider subscribing to the channel if you're new. Give me a thumbs up if you like this particular one. And give me some comments. I love reading the comments. All you guys out there that are 3D printing or thinking about 3D printing, jump on it, man. It's a blast. I have a great time with this thing. And always looking forward to a project that gives me an opportunity to create and 3D print a new piece. Anyway, God bless. Take care.